Today we are doing the notes for task 12.1. I thought I had started the recording before, but I didn't, so I'm just going to describe what I said here. A straight angle is an angle that forms a straight line. A straight angle will always have a measure of 180 degrees. So over here I drew a picture of RST. This is line RT or line RS, however you want to look at it. But the angle, when I'm specifically talking about an angle, the angle is RST. It has a vertex at S. And the measure of that angle, if we were to take a protractor, right, like this, it would be 180 degrees. That's the measure of the angle from 0 all the way to 180 degrees. So the measure of this angle is 180 degrees. That's what happens with a line. So we want you to take a look at these pictures and what do you notice about them? These are supplementary angles. These are not supplementary angles. So if we take these two angles, 45 plus 135 equals 180. And because this is a straight line, the measure of angle 1 plus the measure of angle 2 equals 180. If I look at this pair, 72 plus 118 equals 190 degrees. And this pair is not a line. It's not a straight line, right? So, what do they have in common? These pairs, sum is 180 degrees. Sum is when you add. Pairs mean two angles. These two do not add to 180 degrees. Therefore, the definition of supplementary angles is two angles whose sum is 180 degrees. Now remember, sum means to add the two angle measures. Okay? So in the diagram, these are two examples. This is example 1. 30 plus 150 equals 180 degrees. So that's a supplement. This is a straight line, which is 180 degrees, and those are supplementary as well. Okay, if we turn to page 2, linear pairs of angles. A linear pair of angles these are both examples of linear pairs. These are all not examples of linear pairs. These are not linear pairs. So if you look at this, you should be able to tell what it means to be a linear pair. What do these two angles have in common? These two sets both have two angles that share a side and form a line. That's what they have in common, right? There's two angles. Each pair has two angles. They share a side. So what I mean by this, they share a side, right? This is the ray that's shared between angle 1 and 2 in this picture. And this is the ray that's shared between angle 1 and 2 in this picture. And they form a line. This is the line that they form. Okay, so those are all linear pairs. This pair is not a linear pair. They are not adjacent. Okay, that's what that means to share a side. That's it's a fancy word to share a side. We can call that, if we go back over here, is adjacent. They are not adjacent. So they can't be a linear pair. This pair of angles do not form a line. They are adjacent, but they don't create a line. And the problem with this set is this set forms a line, but there are 3 angles. Therefore, they are not a linear pair. Remember, a pair of angles, pair means 2. Okay, so you have to have only 2. But you need all 3 of these things. You need to have 2 angles, they need to share a side and be adjacent, and they need to form a line. So that is what the definition is. I can write it again for you. So you can write it down, or you can just say it's the same thing. But it is basically, the definition is 2 angles that are adjacent, and by adjacent that means share a side, and they form a straight line or a straight angle, either way you look at it. So in this picture, angle RSU and angle UST are linear pairs. They meet all the criteria, right? So there's 1 is that it's 2 angles, 2 is that they are adjacent, and 3 is that they form a straight line. All 3 things need to be true for them to be a linear pair. So let's think about these 2 things quickly. Are all linear pairs are also supplementary? Is this a true or false statement? Well, let's take each thing at a time. Supplementary, we found out, is if they are supplements, sum is 180 degrees. Linear pairs also sum to 180 degrees. So this is true. All supplementary angles are linear pairs. This statement is false because I can give you an example. If this angle is 60 degrees and the measure of this angle is 120 degrees, 60 plus 120 equals 180, so these are supplements, but they are not adjacent, so not a linear pair. So as you can see, it's possible to be a supplement but not be a linear pair. But if you are a linear pair, then you have to be a supplement. All right, there's one more thing we're going to discuss today. If you were in class, you went through this. You created a triangle sum investigation. If not, I drew 2 pictures in here, so I would like you to pause and take down a copy these triangles down into your notebook, because I'm going to talk about them. The triangle sum theorem states that the sum of the 3 interior angles of a triangle will always be 180 degrees. Always. And so in the triangle sum investigation, you would have went through this process that 60 plus 70 plus 50 equals 180 degrees. And then for the second triangle, 42 degrees plus 105 degrees plus 33 degrees also equals 180 degrees. And in the class, there was about 20 different triangles, and each triangle, when we added them up, they're always going to equal 180. That is always true. So if we use this diagram as an example, you can state that the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. In this picture, we don't know what individually they are, but we know that altogether they'll be 180 degrees. Okay, that is the end of task 12.1. Have a good day. Bye.